Now for the acceleration vectors, when the system at rest, we have at the origin is 0i plus 0j, and at A, the absolute acceleration of A is given by x dot A I plus y double dot j. So if you look at the problem, the roller A and NA is moving, is having a constraint motion. So we have acceleration only in the x direction, so there is be no y direction. So this one, if I want to write back and then replacing the x dot as A, so we have A I plus 0j. Now we're going to evaluate acceleration, absolute acceleration of point G with respect using the kinematic equation. We have G absolute values. The absolute velocity absolute acceleration of A plus the relative acceleration of G with respect to A. Right, I just want to write here, I don't have much space. So for A, absolute acceleration of A is A capital A 0 plus, and then our system here having a angle of 240 degree So the conversion matrix will be cos 240 sine 240 minus sine 240 cos 240, and then the radial direction is r dot double dot minus r theta dot power of 2. Then we have r double dot there plus 2r dot theta dot. So our body is the slender body is rigid, so this one will be equal to 0. And earlier we found that the angular speed of the slender body is 0, and we also assume that term is also equal to 0, and we can then write we're going to reduce this equation further using the symbol lab of tools, metric calculators. So this is a metric calculator that I've shown you before. We have the unit there, and then we have the metric 2 1. This one represents A. Then we have 0 there. Then we have plus. and we have the distance 2, and then the theta, the x will be represent the angular acceleration. So that will be the solution of the so I'm going to write that the A expression G slash O is equal to A plus square root 3 theta dot, and this one is minus theta dot, double dot, right? So we can include that in the Cartesian formal notation for absolute acceleration for G is A plus punca root 3 theta dot I minus theta dot J. Now we're going to look at the point B. So the point B, we're going to evaluate relative to point the mass center G, right? So we have A, B, the absolute values is equal to A evaluated at G, the absolute values, and then we have the acceleration of B relative to G. So this one will be equal to, if I write in the matrix form, so we have A plus square root 3 theta dot minus angular acceleration of the body plus the angle is still the same that we have before, right, when we evaluate G relative to A. So we have cos 240 sine 240 minus sine 240 cos 240. If we have R dot minus power of 2 plus 2R theta dot. So this one is equal to 0. This one equal to 0. And we can write this equation inside the Symbol Lab software. So I share with you the software here. So we have A plus punca root. Let me copy that one. Punca root 3 x, and then here we have minus x. Same with this part, the right hand side. So I just compute the values. So this is the solution that we get. So we have this metric multiplication. So I'm going to write that in our equation. So we have the x dot y dot at b one is equal to a plus 2 square root 3 theta dot there, and then minus 2 theta dot. So when we write the equation in the standard format, we have a b, the absolute values is equal to a plus 2 square root 3 theta dot I minus 2 theta dot j. So when we look at this equation, the theta, the absolute velocity of acceleration of b actually is going upward because follow the guide, the vertical guide, right? So this is the vertical guide, this is the roller, the bar, and it's already moving in that direction. So we have x dot equal to 0 there. So when x equal to 0 there, so we have these two terms. So what you find that 0 equal to a plus 2 square root 3, the angular acceleration of the slab. We have a equal to minus 2 3. So that will be the value of a. And what about b? Let's say we have y dot b. This one is equal to ab. This one will be equal to 2 dot b there. When we have this value, we can then include inside our equation there. Then we get the absolute values acceleration of g there, right? So when we have a is given, so we have the absolute of g 0. We write in matrix. We have minus 2 3, and then we have plus root 3 dot there, and then we have minus theta dot. So we can then write the equation for absolute acceleration of g will be minus 3 dot 2, and for a will be, for ab here will be 0 here, right? 0 I minus 2 theta dot j, and for a is 2 minus 2 square root 3 theta dot I plus 0j. So that will be the expression of acceleration, the absolute values that for all point of interest. As you can see that we cannot solve this problem because we still have the unknown here, the theta dot values, which need to be calculated with one of the method that we learn in kinetics. So we try with the force mass acceleration relationship to obtain the value of angular acceleration for the slender body.